Part 3, Cosmic Event Horizon. It would be natural to assume that light emitted from a galaxy at or after its time crossing the Hubble surface, outbound after the inflection time, will never reach us in the future because the galaxy's recession velocity from us, at any time after that time, will always exceed the speed of light. This is not correct because the Hubble surface is receding from us. Presently, the Hubble recession velocity is half the speed of light. Light can reach us in the future from some locations outside the Hubble sphere. At any time after the inflection time, there is a distance beyond the Hubble distance for that time, beyond which light will never reach us in our exponentially expanding future. A cosmic event horizon. I haven't done all the calculations, but it is close to the far future Hubble distance, 5340 megaparsecs, for the cosmological parameters as known presently. The events horizon is about 5% closer than this today, but increasing with time to 5340 megaparsecs, so we will just use the far future value. Distant galaxies cross beyond 5340 megaparsecs from us, and radiation they emit afterwards can never be received by us in the future. Later, galaxies that were a little less distant cross over. More and more galaxies cross over as time passes and the universe expands. Let's consider the exponential expansion of our Big Chill future. The Hubble distance will saturate at 5340 megaparsecs, but the scale factor will continue to increase exponentially with time. When will a galaxy that is 100 megaparsecs from us today pass beyond 5340 megaparsecs? 100 megaparsecs today times future scale factor A of t sub 1 equal 5340 megaparsecs in the future, when the scale factor equals 5340 divided by 100 equals 53, and that happens 68 billion years from now. Galaxies that are 100 megaparsecs from us today, 130 times Andromeda's distance, will pass 5340 megaparsecs in about 68 billion years. Any light they emit after that time will never be received at the Milky Way, but their old light will. When our universe is 10 times its current age, all galaxies beyond our Milky Way Andromeda local group will have passed the Hubble surface and the event horizon, and we will never see their new light thereafter. In our distant Big Chill future, we will eventually see far fewer galaxies beyond our Milky Way Andromeda local group, invisible light, and then none. We will continue to see galaxies' old light for hundreds of billions of years to come, though that radiation will be dimmer and highly redshifted due to expansion, the increased scale factor. So a time will come when those galaxies are no longer visible to our eyes, and a later time will come when those galaxies' light is no longer detectable by infrared telescopes. But we will continue to see Milky Way Andromeda stars until they stop shining. This completes the section on the cosmic event horizon.